Esters is one of the carboxylic acid derivative, okay, wherein the hydroxyl part of the carboxylic acid, so originally carboxylic acid is RCOOH, okay, the hydroxyl part of this carboxylic acid has been replaced with an OR, okay, so that is an ester. It's a carboxylic acid derivative, and they are formed via esterification. And this is the reaction of carboxylic acid with alcohol in the presence of an acid catalyst, usually sulfuric acid. So the mechanism for esterification is as follows. The hydroxyl group from the carboxyl part of the carboxylic acid exchange place with the OR group of the alcohol. So this is the carboxylic acid and this is the alcohol. Okay. The hydroxyl part reacts with the hydrogen so as to produce water. And since with this open linkage between uh, this carbon atom and the oxygen here, so sila yung mag-connect. Okay, so that would be the ester. RC double bond O, OR. And with that, esters will always have an acid part, yung merong double bond O, C double bond O, and it will always have an alcohol part, the OR part. Okay? So, example would be the reaction of acetic acid. This is the acetic acid. It has two carbon atoms. And methyl alcohol. Methyl alcohol will have one carbon atom. So mechanism will be the OH from the acid part or from the acetic acid, and the hydrogen from the alcohol will come together or will bind together to form water. And with this open bond here as well as in this part of the alcohol, so this one will form linkage and they're going to produce the ester. So this CH3C double bond O is the acid part and the OCH3 is the alcohol part. Okay, so always bear in mind that esters will always have acid part, the series of carbon atom with the C double bond O or the carbonyl, and the alcohol part with the series of carbon atom with the oxygen. Okay, now how do you name esters? They are usually named as alkyl carboxylate, wherein the alkyl is the name or is the part of the alcohol reactant. So usually they are named as alkyl alcohol like methyl alcohol, ethyl alcohol. So that alkyl name will be adopted. And the carboxylate part is eventually the acid part wherein the IC acid from the acid's name will be dropped and replace it with ATE. Okay? So let's have the rule. The name for the alcohol part of the ester appear first. So uunahin nating pangalanan yung alcohol part, and usually they are on alkyl's name. So they should end with YL. Okay, so the name of the alcohol part is simply the name of the R group of the alkyl or cycloalkyl or aryl. And that is the OR portion of the ester. And then we have rule number rule number 3 rather, the acid part of the ester is obtained by dropping the IC acid in the ending of the acid's name and replacing it or adding the suffix ATE. Okay, so let's have the concrete example. So this is an esterification reaction between ethanoic acid and methanol. Okay, so mechanism is the OH and the H will come together to form water, and the OCH3, okay, this part of the alcohol will bind with the remaining part of the acid such that esters will be formed. So the reactant acid's name is ethanoic acid, and the alcohol name is methanol or methyl alcohol. Okay, in naming, this one will adopt the methyl, so that this is the methyl because that's the alcohol part, and the rest would be coming from the acid's name. We are dropping the IC acid and add ATE, so that ethanoic acid will then become ethanoate. The IUPAC name of the ester produced is methyl ethanoate. There should be two words here, so a space would be found in between the name of the alcohol part and the acids part. For the common name, it will still be methyl because it's an alkyl, methyl acetate. We are not going to adopt the ethanoate because ethanoic acid will have a common name of acetic acid. Dropping the IC acid and adding ATE, the acetic acid will then become acetate. Okay, so methyl ethanoate is the IUPAC and the common name is methyl acetate. Okay, another example. So the hint here in naming esters, you have to find the C double bond O. So you locate the C double bond O and O. The oxygen will determine where is the alcohol part. So reference natin yung oxygen, yung katabi niya, of course, palagi ang katabi niya ay C double bond O at yung series of R. Okay, the series of R will definitely be the alcohol part always. Alcohol part. Okay, and then the one with C double bond O will be the acids part. Siyempre, yung carbonyl group na yan, yung C double bond O na yan, kasama yan dun sa carbon atoms ng acid part. Okay. So, in naming, you have to name first the alcohol. It has two carbon atoms, so that is ethyl. However, there is a halogen, so that would be numbered as 2. Ang reference natin is ang counting natin dito ay magi-start dun sa may malapit sa oxygen. So if this is the alcohol part, so reference natin priority is the carbon atom that bears the oxygen. Previously it bears the hydroxyl kasi. Okay, so this one would be carbon number 1 and that would be carbon number 2. So the chloro will be attached on carbon number 2. So the alcohol part is 2-chloroethyl. And the acid part is composed of 3 carbon atoms. So that is originally coming from propanoic acid, but we are dropping the IC acid and we add the ATE. So therefore, that is propanoate. Therefore, the complete IUPAC name of this structure is 2-chloroethyl. Okay, there should be no spaces here. A space and then propanoate. The common name will be 2-chloroethyl pa rin because the chlorine is being attached on the second carbon atom. But this time, instead of propanoate, it would be propionate because that's the common name of propanoate. Okay. Another example this time, the halogen or the other substituent is attached on the, not on the alcohol part just like this example, but rather the other substituent is attached on the acids part. So naming the system, so this is the alkyl. It is ethyl because it's composed of 2 carbon atoms. And on the acid part, remember that this is carbon number 1 and this is carbon number 2. So that would be 2-methyl because this is only 1 carbon atom. Propanoate because there are 3 carbon atoms in the long chain or parent chain of the carboxylic acid. Okay, so that is 2-methyl propanoate. But for the common name, we are not going to adopt the numbering system. Rather, it would be using the Greek letters. So the second carbon atom will be alpha. Therefore, the common name for this structure is 2-ethyl alpha methyl propionate. Okay, bakit ethyl? This is the alcohol part. Y alpha, Y alpha methyl, because on the second carbon atom of this acid, there is a methyl group that has been attached on it. Propionic, because there are three carbon atoms in the acid's name, propionic acid. However, we are going to drop the IC acid and we have to add the ATE as a suffix. Okay, next example would be this structure. So there's only one carbon here on the acid part, or sorry, in the alcohol part. So that is methyl. Same is true for the common name. And we have how many carbon atoms here? We have four carbon atoms in the parent chain, and there is a substituent alkyl group on this third carbon atom. Okay, so ito yung substituent niya. So with this parent chain, we have four carbon atoms. So that is originally butanoic acid, but we are dropping the IC acid and replace it with ATE. So therefore, that would be butanoate. The substituent methyl, so that's methyl, has been attached on the carbon number 3, being the carbonyl group as carbon number 1. So if this is carbon number 1, then that is carbon number 3. So that is why we are putting 3 as a locant for methyl. Okay, so the IUPAC is methyl space 3-methyl butanoate. But for the common name, we are not going to adopt the 3. Rather, we are going to use the Greek letter beta, because carbon number 3 is beta, having carbon number 2 as alpha. So therefore, that would be methyl beta methyl butyrate. Okay, we're not going to adopt the butanoate anymore, because for the common name, the butanoic acid will have a common name of butyric acid. We have to drop the IC acid and add ATE, so therefore that is butyrate. And the last example would be having an aromatic ring. So this is the alcohol part with reference to that oxygen. So that is propyl, because there are three carbon atoms. And the whole of this is eventually benzoic acid originally. But we are dropping the IC acid and add ATE. So therefore, the benzoic acid part will then become benzoate. Therefore, then the IUPAC name of the structure is propyl benzoate. As for its common name, it will be the same, propyl benzoate, because the benzoic acid will also adopt the common name, benzoic acid. So, walang pagkakaiba sila. Okay?